Section 2.3, significant figures in calculations. This is where we actually use those significant figures and figure out how far we carry out our answer. So our learning goal, adjust the calculated answers to give the correct number of significant figures. So in calculations, we know that, when you've got a number on your calculator and you have a big old long number, you're going, how far do I carry it up? Well, calculated numbers are usually rounded off. Well, the question is how far do you round it off? Rounding rules are based on the correct number of significant figures. So that's an important key. So first of all, we need to know and remember how to just round off. If the first digit to be dropped is 4 or less, then it and all the following digits to be dropped are dropped from the number. If the first digit to be dropped is 5 or greater, then the last retained digit of the number is increased by 1. So when we look at this, if we want this number to be rounded to 3 significant digits, that's 8.42, then we look at the number following the 2, which is a 3. We know we're going to then, that's less than 5, so we know we're going to drop that number and anything after it. So 8.42. Here, or if we were to just do it to 2 significant figures, 8.4, we look at the 2, and the 2 is, obviously less than 5, so we do not round up, we just go 8.4 and drop 2 and anything following it. Now on the 14.780, 3 significant digits would be 14.7. We look here at the 8. Yes, we're going to need to round up, so we're going to go 14.8. If it were just 2 significant digits, 1, 2, we look at the 7. We need to round up, so it's going to be 15. Here we go with the last one. 3 significant digits. 1, 2, 3. We look at the last one. We are going to need to round up. So it's going to be a 3, a 2, a 6, and 0's placeholder. So 3,260. So write the correct value of 3.145 grams when it's rounded off to 3 significant digits and 2 significant digits. So when we do that, 3 significant digits, 1, 2, 3, that means we now look here. Yes, it's 5, which we're going to round up. So we're going to go 3.15 because we round up. If it had been 2 significant figures, we look at 3.1. We look at the next one, the one following it, 4. So no, we don't need to round up. So it's just going to be 3.1. So you'll notice here that that is explained here in this solution. Now, adjust the following calculated answers to give answers with 3 significant figures. Please press pause and see if you can do this, and then come back. Alright, so here we go. How do we figure out when we do some math, for example, 2.8 times 67.40 divided by 34.8, and your calculator gets you this big old long number, how far out should you carry it? Well, the rule is not just whatever your teacher says. That's not the rule. Okay, it might have been the rule, sometime in some other class, but not here. The rule is it has to be to the same number of significant figures as the measurement having the fewest ones. So we look at our values. This one has 2 significant digits, this has 3, this has 4. Your answer must be in 2 significant digits. So what you do is you do the math. Here's your calculator display. We're going to only carry it out to 2 places. 5.4. We look here, we do not need to round up, so it's 5.4. And why is it only to 5.4? Because it is the same number of significant figures as the measurement having the fewest significant figures. There's only 2 in this significant, in this value here. There's 4 here and 3 here. So when we have a dividing, we have 3 and 3. Even if 8.00 divided by 2.00 is just 4, you may be tempted to go, oh, it's just 4. No. The smallest number has, or the value, the smallest amount of significant figures is 3. So that means we have to make this have 3 significant digits. And we do by adding 2 zeros following the decimal. So here we go. Perform the following calculation of measured numbers. Give the answer with the correct number of significant digits. Please press pause and come back. So you will notice that when you do the math, your calculator gets 8.52. And you go, oh, do I leave it at that? Well, let's count up. We have 3 significant digits here, we have 4 here, but only 2 here. That means your answer can only be in 2 significant digits. So 8.5, we look at the next spot over, it's a 2, we do not round up, so the answer is 8.5 cubic centimeters. Now, addition and subtraction rules are different, so please make sure that those rules that we just learned, you realize are applied to not addition and subtraction, but rather only multiplication and division. With addition and subtraction, your answer needs to be written so it has the fewest number of decimal places as the measurement having the fewest decimal places. So in this place in this one we have the thousands, we have hundreds and tenths. So your answer can only be to the 10th spot. So when you add this together, you get 66.102. So since it can only be to the 10th spot, we need to look at one spot past the 1, which is the 0, to see if we round up. Nope. So 66.1. Now then, so this is again addition and subtraction. Your answer can only be to the least amount of decimal places. So this one's to the hundredths and this is to the tenths. Your answer can only be to the tenths. So when you subtract, you get 62.09. It can only be to the 10th spot. We look one spot further, 9. That means we have to round up. So your answer is 62.1. So let's see if you can do this. Press pause and add these to the correct number of significant digits. All right, so when you did that, you see that this is only to the 10th spot. So your answer can only be the 10th spot. We look at the one number following it. It's a 0. We do not round up.